Welcome to Carlton's Math Corner. Today we're going to be learning about real numbers. And before we begin, I'm going to give you something to smile about because learning is fun. And as you are looking at this, make sure that you have your vocab packet out as well as your math journal. Please jot down any in your journal, jot down any examples, any tables, drawings, anything that will help you out in the future for studying for a quiz, a test, for even working on a homework assignment. Okay. Then in your vocab packet, I will let you know which vocab words are important to jot down. Please make sure that you're writing down a vocab or the definition as well as a sketch. And a sketch is just like an example of that vocabulary term. And within your packet, I have everything alphabeticalized. However, I may have, I make mistakes, so I may have missed a vocab term, or I may have even worded it a little bit different, and so it's not, where you think it would be, but it's in there somewhere. And so I left some spaces at the end of the packet for any additional vocab words that are not in the packet. So feel free to use those. You may copy all the vocab words, or you may just copy down the ones that I point out for you. Okay, so let's begin. We're going to be classifying real numbers today, and real numbers is actually a term that you will hear more in 7th and 8th grade. So I'm not requiring you to write it down at this moment. However, I want you to know that it's kind of like the big category in which all numbers are underneath. Okay, and so you are welcome to put this in the back of your packet because it's not within your vocab packet, and so but you're welcome to write it down. Real numbers. So basically, real numbers include every number that you have already learned. So it's all fractions, decimals, integers, which we'll talk about because integers are a little different than, or they probably have not been introduced to you, but they're very similar to whole numbers. Okay. Now, speaking of that, whole numbers are also part of the real numbers category. We are going to focus on one category that's underneath the real numbers, and this category is called rational numbers. This entire year we are going to be working with these numbers, and we're going to be doing different operations. We are going to be like adding, subtracting, multiplying, dividing. We'll be working with them in geometry. We'll be working with them in probability. We'll just be working with mostly these numbers. Okay, and so this category of numbers is called rational numbers. And rational numbers are, well, any number that can be written as a fraction. So here are some examples of some numbers that can be written as a fraction. And some may look familiar to you and some may look brand new, and that's okay. You do not need to copy all of these down in your vocab packet because we're going to talk further about them later on in the year. But this would be a great illustration to write down in your math journal. So let's start off. Whole numbers. Whole numbers, you have been using them since the moment you could count, because whole numbers are all counting numbers, including 0. And the reason why they're in this category of rational numbers is because I can actually create a fraction. For instance, 16 halves, 16 divided by 2, and I get the answer of 8. And so I can create a fraction that gets me to 8. I can even just put a 1 under the 8 8/1. 8 divided by 1 is still 8. And so I can make it into a fraction. So all whole numbers, and there's an infinite number of whole numbers, that means there is a forever amount, can be written as a fraction, and they are under this category of rational numbers. The next one is fractions. Fractions, all fractions, whether they are negative, that's what this little symbol means, they're negative, so they are on the left side of 0 on a number line, or even when they're positive. And so all fractions are rational because they're already written as a fraction. And so they already fit in our definition. Next category are decimals. Because the cool thing about fractions is I can actually take any fraction and I can, take a calculator and I can go 3, like 3/5, I could do 3 divided by 5, and it creates a decimal for me. So no matter what, a fraction is linked to a decimal, and a decimal is linked to a fraction. I can create, 0.75. I know that that is 75. Oops, I meant to make a 5. 75 hundredths, which, because I know that 75 cents is 75 pennies out of 100 pennies. And so 75 hundredths represents this 0.75. And this kind of decimal is called a terminating decimal. It stops. Now the other kind of decimal is a repeating decimal. And this decimal goes on and on and on, and it repeats a pattern. That's what this little symbol on top represents. It's called a repetend symbol. And it shows that this 3 is going to repeat. And this 0.333 is the same as 1/3. And so I can write this repeating decimal as a fraction. Powers. Powers are numbers or expressions that look like this. Now we are going to learn how to use and represent these, but I want you to know that powers actually are just another way to write whole numbers. Okay, they're just another way to write a whole number, and we use them to usually write really big numbers. Sometimes we even use them to write really small numbers. And so just know that powers are in this category of rational numbers because we can write them as fractions. Percents. Percents are within this category because a percent is always out of 100. When I'm working with percents, I'm always trying to figure out how many 1% am I using out of 100. Well, in this case it's 28, so it would be 28 100ths, and I can write it as a fraction. This number right here is called an integer, and this integer is very similar to a whole number. If you notice, it looks like a whole number and it just has a negative on the outside, because integers are actually whole numbers. They include whole numbers, and then they have also the negative side of them, the opposite side of them. And we're going to talk more about these as well, and I don't expect you to know, all the integers or anything like that. I'm just showing you examples of what we're going to use this year. Last two examples. First one is mixed numbers. It has a whole number and it has a fraction. Well, because of this fraction, it puts us in this category of rational numbers. Okay? And then our last one is square roots. And I do not expect you to know how to find a square root, but this is what it looks like. And it is in this category of rational number because if I take a calculator, and I'm going to pull this up, if I take a calculator and your calculator has a square root button, and I do square root of 16 and I hit equals. Notice, look what number comes up. 4. Well, 4 is a whole number again. And so it puts us in this category because it creates a whole number which can be written as a fraction. Okay? So all of these numbers are under the category of rational numbers because they can be written as a fraction. Now over in this other category, these are irrational numbers. And irrational numbers are basically numbers that can't be written as a fraction. And there's really not too many examples of them. The first one is just a decimal that goes on, but no pattern. There's no pattern at all. It just keeps going. And second of all, square roots. Well, I know square roots are in this category too, but this square root is a little different. Notice if I put square root of 7 in here and I hit equals, look at all the numbers that I get. And this is actually the furthest that this calculator will go. So it actually will go on further and further if I had a calculator that had more place values. But there's no pattern. There's, and it does go on infinitely. And so it creates a decimal like this. So that's why it's in this category. And some of you may also recall this symbol, pi. Oops, that's a bad one. Let's try again. But this pi symbol, okay, it's used for circles, and I know that you worked with it last year with circles, but it represents, many of you use 3.14, but it actually goes on infinitely with no pattern. It fits in this category of irrational numbers. Now, today you are classifying them, so you need to be able to put these, different examples within rational category or irrational category. And so take a moment, look at these, see if you can put them in a category. Okay, how about 7? It's a whole number. Which category would it go in? You are right, rational numbers. How about 0.345? It's a terminating decimal. It's a rational number as well. 3/5. Well, it's a fraction already, so that kind of is a giveaway. It's in the rational category. How about -10? It's a whole number, but it's got a negative sign on the outside. You are absolutely right. It goes in the rational category. How about this decimal? It goes on infinitely with no pattern. Yep, this category. And how about square root of 4? Well, if I put it in the calculator, this is what I get. I get 2. So you are absolutely right. It goes in this rational category. How about this one? This is what you would get on the calculator, square root of 11. Yeah, it's irrational because there's no pattern and it goes on infinitely. How about this mixed number? 2 7/8. It's got a fraction in it. It's over in this category. Oh, and I lost my numerator. Okay, nice job. For your exit ticket, I would like for you to complete these 4 categories. I want you to tell me, are they rational or irrational? Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again to learn new concepts.